Hello, so in this video we're going to be talking about how to write out electron configurations, which this is a little bit more specific form from our shell models. There we were just talking about what energy level do our electrons live in. Now we're going to be talking about orbitals. So just for a review, we've got four different types of orbitals. We have S, P, D, and F. In our S orbitals we can hold up to 2 electrons. In our P orbitals we can hold 6. In our D orbitals we can hold 10, and in our F orbitals we can hold 14. So that's the maximum number each level can hold. Now, each part of our electron configuration looks a little something like this. I'm going to write out the most simple one. We got 1s2. Now, what do the parts of that mean? Well, this first part, that 1, tells you the energy level that your electrons are on. So I'll use EL to abbreviate that. Our S that we have here, the letters, those stand for our orbital that we're in. So in this case we are in an S orbital. You could have P, D, or F there as well. And then up here, this 2 tells you the number of electrons that are in that energy level. So in this case we would have a full s orbital with 2 electrons, and it's on the first energy level. So if that was the only piece of our electron configuration, this would be helium. So let's talk a little bit more about how we would find these. So we're going to go ahead and use arsenic as our example, our first example that we're going to do. So arsenic, which now I'm going to go ahead and pull up a periodic table for us. And so if you don't know where arsenic is right here on our periodic table. Right there. So when we write out our electron configuration, we've kind of got to start from up here at hydrogen, and we've got to work our way across the rows of the periodic table until we reach arsenic. So we're going to show every single orbital and energy level that gets us from hydrogen to arsenic. And down here in this box, on this lower left side, actually gives us a handy little note about where our orbitals are. So if you can see, our S orbitals are up here, our P orbitals are over here, our D orbitals are in the middle here, and our F orbitals are down here in this bottom section. So we're going to just take hydrogen and we're going to work all the way across this way, and then we'll go down to lithium, we'll work all the way across this way, then we'll go to sodium, we'll work all the way across here, then we'll go potassium, and we'll work all the way across until we reach arsenic, and that'll give us our full electron configuration. So now that we've kind of looked at the periodic table, we kind of know where we're going. Let's go back to our original page here, which that square got drawn on here for some reason. Sorry, let me fix that up. This should be an F. So for arsenic, we're always going to start at hydrogen, which is on the first energy level, has an S orbital, and as we move our way across to helium, we would get 2 electrons in there, and that finishes our first row. So now we go down a row to lithium. That starts our second energy level. Lithium is in an S orbital, and we move over to beryllium, and that fills our second orbital with another 2 electrons. So we now have a 2s2. As we move across to boron, we now go into the 2p orbital, because now we're on the other side where the p orbitals start, and as we move all the way across to neon, we get a full 6 electrons. So we finished our first 2 rows. We're at 1s2, 2s2, and 2p6, which gives us the electron configuration for neon so far. Now we're going to go down to sodium, and starts 3s, and we move over to magnesium, that finishes that with a 2. Then we move over to aluminum, gets into our 3p orbital, and we move all 6 spots across there, all the way to argon. So we still haven't reached our arsenic yet, so we're going to keep going down to our 4s orbital. Now in our 4s orbital, we move over to calcium. We've got 2 electrons there. Sorry, that 2 looks really bad. I'm going to go fix that real quick. So we've got 2 electrons in that s orbital. And now we move into the d section. And the d section gets really interesting. Because if you remember, for our s orbitals, we started in the first energy level every time because it's in that first row. The p orbitals, we started in the second energy level because it was in the second row. These are energy levels. For d, it starts in the fourth row of the periodic table, so you'd think that it would start with 4d, but actually it follows a pattern where it'll actually start in the third energy level. And this is why, as we're going to talk about valence electrons later, that section doesn't contribute to our valence electrons. And F, even though it doesn't start until the 6th row, it'll be in the 4th energy level. So knowing that, we go from our 4s orbital to the 3d orbital, because it starts in the d. And we move all the way 10 spaces across, so we fill that up with 10. And now we're at zinc, we're almost there. So our last part of this is we're going to get into our 4p section. And to get to arsenic, we need to go 3 places in, so we get to a 3. So we would get 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p3. That would be our electron configuration for arsenic, right there. So that takes a long time to write out. So we're going to go ahead and find an easier way. So let's take an element like, let's do radium. So for radium, its abbreviation is Ra, which, when we pull up our periodic table, is way down in the bottom left-hand corner, number 88. So we'd have to go through 6 whole rows worth to get down there into that 7th row to get to radium. That would be a lot of writing out if we had to go all the way there. But luckily for us, we don't have to write out every single thing. We can use what's called noble gas notation. So if we look back to our periodic table, we find the noble gas that came just before the element we're looking for. And then we just fill in from there down to where we're going. So, for radium, the noble gas on that far right-hand column that's right before radium is radon, or Rn. So what we do is we put that noble gas in brackets. So we put Rn in brackets. This tells us that everything before what we write here, this goes from 1s2, 2s2, and goes all the way down until we get through 6p6. So it fills in all that information for us without us having to write any of that out, which it gets really annoying when you have to go that far down and actually write all that out. So this saves us a lot of time instead of having to write all of that out. So that's what that radon part stands for. And now we're just going to finish off going from radon on the periodic table to where we're going, which radium is real close. We go into the 7th energy level because now we're in the 7th row. We're in an s orbital. And radium is the 2nd element across. Sorry, my pen's not wanting to work with me here. So we're in the 7s orbital. Gosh. 7s orbital. We're 2 elements in, so we would get a 2. And that would be our electron configuration for radium. So normally we would have to write from 1s all the way across to 6p, and then we would write that 7s part. Now we just get those 2 simple little things. We get the radon plus our 7s2, and that would give us our electron configuration for radium. So that's everything that you need to know about writing electron configurations out fully or in noble gas notation.